Okay, we have an electric field here as shown by this field pattern. Since the field is directed this way, and remember the E field is always pointed from high to low potential, this immediately tells us that Vy is a higher potential than Vx. This has nothing to do with the density of the field lines. The density of field lines only tell us that the field strength is stronger here and the field strength is weaker here. It's the direction of the electric field that tells us that the potential is decreasing towards the left. Okay, so since this is an electron which is negatively charged, it must experience an electric force that's in opposite direction to the direction of the electric field. Oops, sorry. So the electric field is pointing to the left, right? So the electron is experiencing a electric force to the right, okay, because it's negatively charged. Field points one way, the force it experiences is in the opposite way. If the electron experiences a force rightward and is going from left to right, that must mean that in going from here to here, it was gaining Ke. So this gain in Ke came at the expense of the loss in EPE. The gain in Ke can be written as half mv squared, where v is its final speed, minus away the initial Ke, which was 0, because the question told us that the electron started from rest. How much EP did it lose? So the amount of loss should be equals to the, we are going to use Q times delta V, right? So the charge is E, and the difference in potential is Vy minus Vx. If you are framing it this way, the loss, whatever here, must be a positive number. So we are just going to use the 1.60 times 10 to the power of negative 19, ignore the negative sign. But here we got to arrange it such that this thing gives us a positive number. So since Vy is higher than Vx, we should take Vy minus Vx and not the other way around. So from here, you rearrange the thing, you should be able to get the velocity, which is this guy here, to be 2e divided by the mass, and the mass is the mass of the electron, and this equation here. So the speed is proportional to Vy. Wait, did I forget something? Oh, I forgot the square root. Let me see. V is here, 2m, and then I'm going to, yeah, the whole thing is inside the square root. But anyway, the important thing is V is proportional to the square root of Vy minus Vx. Now there's another way to do this question. Many people actually find the second way easier, and that is to apply the principle of conservation of energy, but not in the gain loss form, but in the initial final form. So the initial Ke plus EPE should be equals to the final Ke plus EPE. So the initial Ke is initial K is 0, right? It started out being 0. And the initial EPE, that's the EP when it's here. So to get EPE, we are going to take Q times the potential there. If you are doing it this way, then be careful. If the charge is negative, you got to put it as negative. So the charge of an electron is negative E, because it's negative 1.6 times 10 to the power of negative 19. And the potential here is simply Vx. Its final Ke will be half mv squared, and its final EPE will be negative E, because that's the charge of the electron, times the potential there, which is Vy. So this equation here is it the same as this one? Yep, it is. So you're going to get the exact same answer. Alright, so you either apply PCOE using the gain equals to loss way, or you can do it using the initial equals to final way. Both should give you exactly the same answer.